The first vulnerability that we want to really dive into today is the persistent XSS in Adobe Experience Manager. The funny thing about this one is that we found it 3 separate times. So they tried to patch it 3 times, and we found bypasses every single time. So when you look at Adobe Experience Manager, it is a pretty popular technology with about 40,000 exposed assets on the external internet. Whenever you visit an Adobe Experience Manager asset nowadays, you may have not noticed this, but there's actually a component called the RUM collector that's running on all of these pages. Adobe Experience Manager does have 2 different deployment strategies, either on-premise or cloud. And today we're specifically talking about bugs inside the cloud version of AEM. So whenever we visited an AEM asset, we saw this snippet of code that got us quite curious. It was loading some JavaScript from this path, this .rum path, and we started wondering, how does this actually really work? So yeah, as I said, there's 2 types of deployments. There's on-premise versus cloud. And over the last few years, most customers have moved to the cloud offering. The interesting thing about the cloud offering is that you don't actually know what's running on that cloud version of AEM. Not everything is under your control. And this is really the case for the .rum path. It's actually running on Fastly at Edge platform, which is a platform that Adobe uses as a CDN to serve certain things. We were quite surprised because this whole .rum path was actually a open source project that Adobe had published on their GitHub called the helix-rum-collector repository. So we started digging into some of this code to understand what's really going on when we hit that specific path that's being reached every single time you visit an AEM asset. The RUM collector actually is just to collect user experience metrics. Even though it looks like it has some interesting functionality, its core reason of being there is to collect some metrics from the users around how their experience is, the time taken for certain things to load, all sorts of metrics that can be used for Adobe to understand how fast their sites are really going. So yeah, as I mentioned earlier, this repository is available on GitHub. It still is today. So if you're interested in how some of this worked, you can always take a look at the repository as well and look through the commit history there as well. This is kind of a dangerous part of being cloud hosted in general. You don't have full control over all the different components that are being ran in your environment. So it is an interesting case study there as well. To understand how this RUM collector really worked, we need to understand what its primary function was when it was to deliver JavaScript to the user. What it would essentially do is proxy a request to one of 2 CDNs for NPM repositories, either unpackage or JS deliver. The way that it did this was that it would first check the path for a match. So does the path start with this specific string? And if it does, it would then at random pick either unpackage or JS deliver as a CDN provider. And after doing that, it would figure out what path to obtain from the NPM repository. So it would strip the /.rum and it would calculate the exact repo and file to obtain from NPM. Then it would pretty much just straight out fetch that content from NPM through one of those CDNs and serve it directly to the user. So if you're someone that has a bit of an offensive security mindset, you can understand that if you were able to proxy arbitrary packages from NPM, then maybe a security vulnerability there. And that's exactly what we were thinking when we were looking at this specific mechanism inside AEM sites. So proxying to NPM packages, what could go wrong? I mean, the fundamental flaw with the RUM collector is that it took some sort of user input, transformed it, and directly proxied it to these NPM CDNs. And while the developers did make an attempt at ensuring only Adobe or RUM packages are proxied, there were quite a few flaws that made this not the case. So the first XSS we found was the RUM collector was just checking whether or not the path name started with a specific package name. And this is quite interesting because if all of our requests are being proxied to one of these CDNs for NPM, we can just basically register a package that starts with web-vitals. And then we should theoretically be able to proxy that package through this RUM collector. So this specific check, this path name that starts with, it's missing a trailing slash, which means that we can pretty much proxy any package that starts with web-vitals. In this case, we could register an npm package called web-vitals-malicious, add a static HTML file to the npm package, and then the RUM collector would happily proxy to that package. Since npm isn't strictly limited to JavaScript, we could host whatever type of files we wanted inside the npm package and publish it on npm.js. This would allow us to proxy any of those files through any AEM site on the internet. So it's quite serious in nature in the sense that it does lead to persistent XSS, as well as the ability to serve arbitrary files on any AEM asset on the internet. As I mentioned, there's over 40,000 assets that are running AEM on the external internet. So what was the fix? I mean, they pretty quickly fixed this one, and they said, okay, well, we're going to make sure that the path name ends with a slash. So they added this little regex here, which ensures that the path name ends with a slash. Is it really secure yet? Well, we were quite skeptical, and we started digging a little bit further into this. The second XSS actually relies on a little-known feature of Node.js. So looking at the proxying logic, we couldn't just provide a arbitrary package anymore. We had to get a little bit creative with our payloads. And naturally, we tried a lot of payloads that attempted directory traversal. That seemed like the next logical step. If it has to end with a path, why don't we try and traverse backwards through one of these CDNs and hopefully end up to the package that we want? Unfortunately, they already kind of had some sort of logic to prevent basic path traversal in this proxying mechanism. But when we dug a little bit closer into this, we found that Node.js from version 18 uses the Ada URL parser library. And inside this library, there's this following code snippet. It essentially says, if the URL has any tabs or newline characters, we should strip them before we actually fetch a URL or go to a URL or do anything with the URL. And this is really interesting. And this is something that's way, way more broadly applicable to the wider ecosystem than just Adobe AEM. Because the Helix RUM collector did have some sort of protection for directory traversal, but they didn't know about this little-known feature of Node.js, we were able to leverage this to be able to get the XSS the second time around. How this manifested itself was essentially we came up with a payload where instead of just // we would do %09 / which wasn't picked up by Helix RUM collector. But when parsed by the Ada URL parser library, it would just be // because it strips the tab character, which is %09 in this case. So this basically bypassed the explicit filter that Adobe put in place. And ultimately, when the fetch happened, we were able to traverse back and reach our arbitrary malicious package that we created earlier. The result of this was that we got persistent XSS for the second time around. And this technique is really cool. It's something that I would really keep in mind when looking at Node.js applications, because if anyone makes the same mistake Adobe did with the explicit filter for the // without knowing about this parser configuration and how it works, then they could be opening themselves up to directory traversal as well. It's quite a widely applicable technique. So how did this really work? Let's step through it step by step. So the proxy first passes it to unpackage minus the /.rum, and it will see the web vitals path with the // as well. Since we didn't specify a package version, it will URL decode it and then send a redirect. This means that the location header turns into .tab./ with where the tab is a literal tab character. The location header gets passed again. It will remove the literal tab character because of what we saw in the Ada URL parsing library, resulting in a proper traversal going back to our actual malicious package. So it's quite interesting to see all this play out. There was a bit of a trick to ensure that we would get to this stage by basically not providing a version, and that meant that it would cause a redirect, cause the ADA URL parser library to process it, then cause the traversal, which would then ultimately lead to the persistent XSS the second time around. So what about the third and last XSS? And what was the fix for the second one? So the way they fixed the second one was they rejected all encoded characters except %5e. But you can see that the way that they've done this isn't necessarily super sophisticated. They've got a valid version pattern, and they're just seeing whether or not the path segment includes that valid version pattern or a percentage. It was quite interesting because it almost seemed like these patches were being generated by AI or something like that, because they hadn't seemed to have gone through rigorous testing themselves to ensure that they couldn't bypass these security boundaries that they put in place. The third XSS, the final logic flaw, was actually quite simple. We just did the same thing as the second XSS, but we appended a %5e after a question mark at the end of the URL. This meant that it was trivially bypassable, and we were able to get the XSS for the third and final, hopefully final time. So this was the last fix, hopefully. In this case, they pretty much make sure that nothing other than a %5e character is accepted by the Helix run collector. This means that if you provide anything else in a URL encoded format that's not %5e, which is a caret character, then Helix run collector should just completely disallow you from being able to hit that path. For the listeners that are using Adobe Experience Manager, what's the remediation here? Well, essentially, there's 2 CVs that were assigned for this. And fortunately, if you're an AEM cloud user, even though we talked about all the risk of being a cloud user in general, one of the benefits you get that is that when there are vulnerabilities in centralized components, there's really not much for you to do. Adobe has already patched this issue. And kind of staying true to the Christmas in July spirit, we're not trying to get you to worry about these vulnerabilities in a holiday period. There's nothing for you to do right now. This has already been patched across all Adobe Experience Manager instances on cloud. For those that are on premise, this doesn't really affect you because you wouldn't have a Helix run collector on premise versions of Adobe Experience Manager.
Thank you, Shah. And just very quickly on that as well, I made a note earlier that you mentioned, for those with an offensive security mindset, they'll immediately see the risk. Not everyone has as sharp eyes for you, especially when, this is slipping by a company with 30,000 plus employees and you're able to identify this. Is there something for the broader security community you wish they would understand just in general with both the vulnerability you just talked through, but the other 3 that are yet to come as well?
Yeah, I mean, the risks generally when it comes to business and XSS is something that people in the offensive security space would know, is that you can host arbitrary content on websites, including arbitrary scripts, which means that you can execute arbitrary JavaScript in the context of a victim. You can also, affect brand reputation by hosting defacement websites, or you can do even worse by phishing users of these websites. Now, given the context of Adobe Experience Manager being ran most of the time on the main websites of most companies, their landing pages, that's why this was a really important vulnerability. It's because most major brands are using Experience Manager pretty much for their main core website for marketing, which meant that this vulnerability allowed attackers to essentially, all the way ranging from execute arbitrary JavaScript in the context of the victim, all the way to running phishing campaigns on the websites of major companies and brands. But yeah, that was the risk for Adobe Experience Manager.